In this video, I introduce temporal ensembling for semi-supervised learning. Temporal ensembling is a semi-supervised learning method to train deep neural networks using labeled and unlabeled data, where amount of the labeled data is only a small portion. For example, labels yi available only for the labeled data, and the standard cross-entropy loss is evaluated only for the labeled data. A training dataset consists of n inputs xi, where I from 1 to n, and c labels yi. Pi model evaluates for each training input xi twice to produce two predictions zi and zi tilde, as shown here. This is the input xi. This is the two inputs to the stochastic augmentation and the network with the dropout. This is the label of the labeled input data. The weighted sum is used to train the semi-supervised learning model. The standard cross-entropy loss is used for the labeled data, and the mean square difference is used for predictions zi and zi tilde for the same unlabeled data xi. Due to the stochastic augmentation on the input data and stochastic options in the network model, the network outputs zi and zi tilde are different. And the cluster assumption, the similar unlabeled input data should have similar outputs. Pi model further classifies the training dataset once without updating the model with theta, and then the training network on the same inputs and different augmentations and dropout using just obtained predictions as a target for the unsupervised loss component. As the training targets are based on single evaluation of the network, they may be noisy. Temporal ensembling elevates this issue by aggregating the predictions of multi-previous network evaluations into ensemble prediction, which evaluates the network only once during training, and therefore is faster than the Pi model as shown here. This is the input. We only simulate one time to get zi, and this label for the label data, and this is the cumulative ensemble target. We use standard cross entropy and mean squared difference to train the semi-supervised learning model. Temporal ensembling evaluates the network and augmentations only once per input epoch, and the target vectors z tilde for the unsupervised loss component are based on previous network evaluations instead of a second evaluation of the network, as shown here. After every training epoch, the outputs zi accumulate into ensemble outputs zi by updating z from z old and zi, where alpha is a momentum that controls how far the ensemble reaches into training history. Because of dropout regularization and stochastic augmentation, Z contains a weighted average of the outputs of the ensemble of network F from previous training epochs, with the recent epochs having larger weights than distant epochs. The training targets Zi are normalized by 1 minus alpha t to correct the setup bias in Z, as shown here. This input xi, this augmentation function g, and this network f theta, this output zi. For the label data, we use the standard cross entropy to measure the difference between the true target and the prediction. For the unlabeled data xi, we use the mean squared difference to measure this zi tilde and the output zi. as shown here. And this is the pseudocode of temporal ensembling model. For more details, please check with these references. Thank you. Bye.